At what altitude above the Earth's surface is the gravitational field strength equal to G over 7? And we're assuming that G is the gravitational field strength at the surface of the Earth. And, yeah. All right, so. So G is, I would probably show what that is. At surface. Why does the one thing I would make sure I show my understanding of is that the gravitational field gets less the further I get away from the center of the Earth. All right. How far is the surface of the planet of the Earth away from the center of the Earth? Or not half the radius, but the radius away. So the value at the surface is because the surface is one radius away from the center. And now we're going to go even further away because we know as we move further from the center of the Earth, from the center of mass of the Earth, the gravitational field gets less and less. So I would put something that showed I understood that. The further from center of mass of Earth, the weaker the field. The weaker the field. So showing that I understood what they're referencing with little g, and then that we get the further from the center, the weaker the field. Those, I would say, are the two really strong points to have in your watch. All right. You could go to to be even more specific under the second part and say that it's an inverse square law. You know, or that it falls off really quickly but never goes to zero. Things like that, showing that you understand that relationship. But I would say that, you know, if you didn't have that, it would still be showing that you fully understood the problem. Any questions on the why before we move to the how? Good? All right. So now we can do this. Either we can put in numbers of 9.8 and everything like that, you know, newtons per kilogram. I'm going to do it by trying to have to look up as few numbers as possible, is what I'm going to try. All right. So I know if I grab my equation sheet, which of course I didn't open up, but let me pause for a second and grab my. All right. So from my equation sheet. All right, so now that we got things unfrozen, but we've lost our background, I'm going to use, starting on the line, I'm going to use the equation G equals big G MP over RP. So I'm just going to write that again, rather than copying it. Big G MP over RP squared. So remember that R is referring to how far I am from the center of mass. What I had there in my Y. Let me cast out again. Huh? The P is because a lot of times we're talking about the planet having the creating the gravitational field. So subscript is planet or person or whatever is creating the gravitational field. All right. So for this on the surface of the Earth, we know the value of little g, right? The value of little g on the surface of the Earth is 9.81 newtons per kilogram. Right? We've been using that for a while. The way that value is gotten, so g, that would be from the gravitational constant, big G, and then we'd use the mass of the Earth, and because we're on the surface of the Earth, you'd use the radius of the Earth on the bottom. All right? But we don't want G, we want 1/7 G, and we want to know how far are we from the center of the Earth, right? Or does it ask, at what altitude above the Earth's surface is the gravitational? So, what we want to know is how far we are from the center of the Earth minus 1 radius. Remember our surface here, if we were to do a diagram, here's the center, this is radius of the Earth, we're somewhere up here, and they want to know this height, h, here. So I'm going to write what we want to know, minus 1/7. What's other people's? 1/9, 1/4. So, okay, so you have a whole, but everyone has a whole number down there. So I want to find out when we have G over 7, that's going to equal big G, still the mass of the Earth, because it's still the Earth that's creating the gravitational field, right? But now I've got h plus the radius of the Earth, that quantity squared. Height is what I'm calling how far above the surface of the Earth I am. Now, you could just go in and plug in, oh, I know what little g is. That's 9.81. I know the mass of the Earth. I can get that from my equation sheet. I know the radius of the Earth, and you can get h. Or you could plug in and do some calculating. I think it's actually easier at this point to probably put in our numbers and do it. We could mathematically, substitute in this blue for little g, and you would notice that like big G would cancel out, mass of the Earth would cancel out. Actually, why don't we do that? Let's make our life a little simpler. Let's do a little bit of both. Not just throw all numbers into the green equation here, but throw in a little bit of the blue equation. And that way, maybe we make our life easier in the calculating part. All right? Yes? No? Okay, let's give it a try. And if it isn't easier, then we can always go back and just throw numbers into the green equation. So, in the green equation, I'm going to substitute in this blue stuff. I'm going to get big G, mass of the Earth, over, I'm going to keep that green 7, but have radius of the Earth squared down here, and keep this whole big side of the green equation. And there I've substituted in, anything cancel out. Anything the same on both sides of the equation. What? The big G's, they're gone. The masses of the Earth, they're gone. Could I cancel out the radius of the Earth too? No, because it's more complicated than that, right? But I could rearrange this. Here I've got everything on the bottom. Could I kind of bring these up by cross multiplying? Sure. So I'm going to write my equation a little simpler and say, well, h plus radius of the Earth squared equals 7 radius of the Earth squared. Could I square root both sides? That'd make life a lot simpler, right? If I got rid of the squares. They bug me anyway. So let's square root both sides. So throw a square root here and throw a square root there. Everywhere a square root. So, sorry. Equals square root of 7 and just radius of the earth. Oh, now I can plug in. Now I could. I'm interested in h. So now I get that h equals square root of 7 times radius of the earth minus the radius of the earth. Yeah, so then I can just plug that in. I'm going to do one more simplification. Radius of the earth times square root of 7 minus 1. And now I can just plug in the numbers. Where can I find radius of the earth? I did what's called factoring. I noticed that both my terms had a radius of the earth in it, so I factored it out and brought it out front. Yeah. Where can I find the radius of the earth? On my equation sheet. My friend, the equation sheet. And it's right here. Our earth. 6.38 times 10 to the 6th meters. Think I should use meters? Yeah, I think I should use meters. It's 6.38 times 10 to the 6th. So my h is going to be 6.38 times 10 to the 6th, so 1,000,000 meters times square root of 7 minus 1. And I hope I got it right. Oh, maybe it was my calculator that froze last time. Well, I'm going to use my manual calculator, see if my virtual one there works. All right, so we're standing on a new planet, planet Cochran. Planet has a mass of this and a radius of this. What is the gravitational field on the surface of this planet? Why is there a gravitational field? Huh? Anybody? Why is there a gravitational field on the surface of the planet? Because it has mass. So that's a great first point. I know it seems too simple, but planet has mass, so creates field. I would also put in there something along the lines of larger radius, less, or I don't like the word less, weaker field. And maybe even less mass. Weaker field. You're showing you understand why there's a gravitational field. You're also showing that you understand the two factors that control how strong that field is, the amount of mass there and how far you are from the center of that mass. Both those are your contributing factors. So from our equation sheet, we grab the same equation. Gravitational field strength is gravitational constant, mass of the planet over the how far we are from the center of the planet squared. In this case, we're on the surface, so we're 1 radius away, right? And now, let's see. Double check. What do we know? We know the mass of the planet in kilograms. Is that our base unit? You know a way to double check your base units? Where do you think it is? On the equation sheet. Look at this. Unit symbols. All the base units we use are right there. So is kilograms my base unit? Let's look. Oh, Hertz, Newton. Kilogram. It's in the list. It's a base unit. Kind of cool. More and more reasons to use your equation sheet. And a radius of this. It's in meters. Oh no. Do I have to convert that one? No, because it's on the list, right? Oh, all these things. So, wait a minute. We know everything then. We know big G. Uh-oh, where's big G? Where do you think you'd find out the value of big G? On the equation sheet. Wow. So, let's put in some numbers that we have from our equation. So big G, I know I looked it up earlier, 6.67 times 10 to the negative 11 Newton kilograms per meter squared. Mass of the planet, 3.929 times 10 to the 20th. 3.929 times 10 to the 20th kilograms. I'm getting jammed for space, sorry about that. Over the radius, how far I am from the center, 2.280 times 10 to the 6th. I gotta look at better resolution than I have on the board. 6th. 2.280 times 10 to the 6 meters. 2.280 times 10 to the 6 meters square. And use my happy dandy calculator. No, my calculator that someone borrowed is, I think I've moved it up to stolen, unfortunately. But I have my backup calculator. Well, if anyone does find it, I am more than happy to accept it back. Huh? It's one of the TIs. It's one of, well, it's still kind of round. It's like this kind of black, silver, but it's not like skinny. Yeah. I know all the people who I got 0.005. Let's see if that's right. I would give it 3 since it doesn't say. Good, and mine is. I probably should have given a little more there. But let me write in that answer. So I got 0.0050412,492 newtons per kilogram. Most common mistake is to forget the squared on the bottom or to mess up your order of operations, especially if you don't use your, what I call the EE key or the exponential key, which is right above, which is shift or second comma. If you don't use that key, a lot of times that'll mess up your order of operations. And then I'm asked if you have a mass, for me it's 169 kilograms, what's your weight on planet Cochran? So I remember my equation from my equation sheet that says the force of gravity, which is also known as the weight, is mass times the gravitational field strength. Watch your language, please. Substitute in. What was my mass? 169 kilograms. times the gravitational field strength on good old planet Cochran. And I get, oh nice, that number's already stored in my calculator. 0.852 newtons. Planet Cochran's more of an asteroid than in my case. Woo-hoo. Mountain G. So, what should I put for my Y here on the mountain? There's no trig in these. Radians doesn't matter. Only if you have, trig function, sine, cosine, tangent. Anybody? What should we have for our Y here? We've done a couple like this. Come on, you can do it. I'm going to put both those because both those are good. Why does the height of the mountain affect the gravitational strength? The higher the mountain, the... Since it's the higher the mountain, the further you are from center of mass. Right? So you go up on the mountain, you're further from the center of the earth. Oh, so where in the United States would have the highest G value? No, in where in the United States would have the highest G value if the taller. What's our lowest point in the United States?
Oh, the United States.
Death Valley. Death Valley is our lowest point. What's our highest point in the United States? It's actually in Alaska. Denali, Mount Denali. Used to be Mount McKinley before they changed his name. Well, the president issued an order. We had to call it something different. And let's see. Someone said, Danielle, was it you? There's gravity because the Earth has mass. Yeah, that's the other one. Grav field since Earth has mass. Bless you, by the way. Yep, just like before. What I'm going to draw down here, I'm going to draw my little picture again. So here's the Earth. There's the mountain. We're talking about the top of the mountain. So from the center, we've got the radius of the Earth plus however tall the mountain is. I think that's similar to the drawing that was included here, right? Yep, they're showing that the radius of the Earth that the radius of the Earth goes up to the bottom of the mountain, and then this height is measured from the surface of the Earth to the top of the mountain. So mine's 3,400 meters. Again, I'm interested in the strength. So for my equation sheet, I'm going to grab little g, big G, mass of the planet, radius of the planet squared. In this case, I'm going to have G. Our universal, we'll use our universal constant, mass of the Earth, over. Now, remember, that's how far I am from the center of the Earth, the center of mass of the system. So that's going to be the radius of the Earth plus however high I am above the surface squared. Bless you. Do I know the mass of the Earth? Yes. Where can I find it? On the equation. Do I know the radius of the Earth? Yes. Do I know the height? Yep, it's given to me in the problem. So